Lesson 6.2 is looking at different properties of exponents. So I'm going to give you some rules that will make life a lot easier, but the great thing about properties of exponents is a lot of them, if you forget the rule, you can still figure the problem out. You're not totally in trouble. So our learning goal today is I will simplify expressions using the properties of exponents. Now, this is something that I've seen when you guys take your standardized testing. I see these problems on there all the time, and you're usually like, oh my gosh, this looks ridiculous. What on earth am I supposed to do? I shouldn't be talking while I'm trying to write. I will simplify expressions using the properties of exponents. They freak you out. These problems always look, exponents, I spelled exponents wrong. They always look a lot harder than they are, and that'll teach me to talk while I'm trying to write. Anyway, but there are really just a couple of rules you need to know, and they make life really easy. They make simplification really easy, and let's just hop to them. So starting off with, we're going to talk about the product of powers. So the product of powers property. Product means to multiply. So what I'm doing is I am multiplying two numbers together with the same base. The key for all of these is we need the same base. Remember back to when we learned about exponents, like 2 to the 5th. This 2 is the base. The 5 is the exponent. And the whole thing we call the power. So this is 2 to the 5th power, or 2 to the 5th. So we're talking about things multiplying two numbers together, two powers that have the same base. For example, if I had 2 to the 3rd power times 2 squared, I want a way of simplifying this. Now, what I could do is I could break it into what it means. Remember, 2 to the 3rd power is 2 times 2 times 2. 2 squared is 2 times 2. If I look, I have a whole bunch of 2's here, or I have 5 2's. So I could write this with an exponent as 2 to the 5th power. Now, I can do that by writing it out. However, that's not going to work if one of those is a variable. So we need a rule that's going to work all the time. And what our rule is, if we are multiplying two powers together with the same base, I can just add the exponents. So that would be 2 to the 5th power. So I don't actually have to write out 2 times 2 times 2 times 2 times 2 to get 2 to the 5th. I just know that because I'm multiplying these and they have the same base, I can add the exponents. So that means if, like in your book, they show it with variables or with, algebra. If I have a to the m times a to the n, so I have the same base here, this can always be simplified as a to the m plus n. So if you forget though, you can write it out this way, but it's good to remember that rule. We also have a rule talking about the quotient of powers, which is exactly the same, but now we're dividing. So if I had 3 to the 4th power divided by 3, how about 3 squared? Again, I could write it out the long way. That would be 3 times 3 times 3 times 3. My denominator would be 3 times 3. And then you'd see I have a couple of 3's that I can simplify out. I can factor out a 3 here, I can factor out a 3 here, and I'm left with 3 squared. But instead of having to write that whole thing out, you could also see that I am just subtracting my exponents. So another way to write that, 3 to the 4th over 3 squared, would be 3 to the 4 minus 2, or 3 squared. So with variables, a to the m divided by a to the n equals a to the m minus n. And that makes life quite a bit easier. And then one other thing is doing power of a power. So that would be when we have a situation like 2 squared cubed. So I'm doing the power of a power. If I write this out the long way, it's 2 squared times 2 squared times 2 squared, or 2 to the 6th power, because 2 plus 2 plus 2 is 6. Another way that I could have written that, though, 2 squared to the 3rd power is just 2 to the 2 times 3 power. So in this case, we're going to multiply the exponents when it's the power of a power. Using algebra, if I have a to the m to the n power, that's just a to the m times n. So those are all of our rules. I shouldn't say all of our rules. Those are a couple of the rules for simplification. The rule that everybody hates is the negative exponent rule. So if you have a negative exponent, for example, 3 to the negative 2, that negative sign is telling me to take the reciprocal, or to flip it over to the other side of a fraction. So if I thought about 3 to the negative 2 over 1, a way to write this using a positive exponent would be to flip it over. So it's 1 over 3 and make the exponent positive. 1 over 3 squared. So 3 to the negative 2nd power is the same as 1 over 3 squared. Or x to the negative 3rd power is the same as 1 over x cubed. When I flip it over into the fraction, I get rid of that negative sign. Notice that that negative sign has absolutely nothing to do with this fraction being positive or negative. What it does is it flips it over. It tells me to take the reciprocal. If I have a negative exponent in the denominator, 1 over x to the negative 2, then when I make this exponent positive, I'm going to flip it over, and I get x squared over 1, or just x squared. So that's what the negative exponent is telling me to do. I'll do a couple examples in a second with negative exponents so you can see what that really, you can see how you'll see them more often. Finally, one more rule. The 0 exponent. Anything to the 0 power is 1. So 5 to the 0 power is 1. X to the 0 power is 1. 1,217,354 to the 0 power is 1. Oops, I ran out of room there. But no matter what it is, if it's raised to the 0 power, it's 1. So a way to write that using algebra, a to the 0 equals 1. And I just realized I forgot to write out our algebra for the negative exponent. If you have a to the negative m, that's the same as 1 over e to the m. So that's how you would show that algebraically. So let's get to a couple of examples. So here are 3 quick examples of what we want to simplify. For the first one, we're simplifying negative 5 to the 3rd times negative 5 to the 6th. You know that you're simplified when you only have one of each base. So here I have 2 negative 5s, so I have to figure out what to do about that. Because this is negative 5 cubed times negative 5 to the 6th, I could show this as negative 5 to the 3 plus 6, or negative 5 to the 9th power. And that is totally simplified. For number 2, this is a quotient of powers problem. So I would write this as x to the 4 minus 6. I subtract my exponents, and I get x equals negative 2. However, you'll see a lot of times that the problem will say, write your answer using only positive exponents. I have a negative exponent right now, so I need to remember that that means take the reciprocal and make your exponent positive. And then finally, I have 7 cubed to the negative 5th power. So that means 7 to the 3 times negative 5. And I get 7 to the negative 15th. Again, this is kind of simplified, but I do have a negative exponent, so I need to take the reciprocal and make the exponent positive. So these are all some pretty simple versions of what you will see. 2 other things you need to know while simplifying have to do with the power of a product and the power of a quotient. So the power of a product would be something that looks like this. You have a product and you're raising it to a power. And I kind of think about these rules as like the distributive property for powers. So if I had 3 times 2 to the 5th power, now of course I could do 3 times 2 and get 6 to the 5th, right? But this could also be written as 3 to the 5th power times 2 to the 5th power. In this situation, not necessarily helpful. However, if I had 3x to the 4th, this is where it could be more useful. 3 to the 4th times x to the 4th. Or a way of showing this with only algebra, if I had ab to the m power, this becomes a to the m times b to the m. The power of a quotient is really the exact same thing. If I had 3 over 4 to the 3rd power, I could write this as 3 to the 3rd power over 4 to the 3rd power. Or if this were x over 5 squared, I could write this as x squared over 5 squared. Or just using algebra, a over b to the m power is a to the m over b to the m. So I think this is a pretty, self-explanatory rule, but here are a couple of ways that it can be applied. And here are a few examples of how I'm going to use those rules that we just talked about. So for the first one, I have negative 2x cubed. This is a product being raised to a power. So this would be negative 2 cubed times x cubed. Negative 2 cubed is easy enough for me to do in my head. That's just negative 2 times negative 2 times negative 2, or negative 8, and I'm going to leave the x cubed how it is. So negative 8x cubed. It says to write my answer using only positive exponents. I only have the exponent of positive 3, so that rule, I don't need to worry about that. Here I have the quotient, or I have a quotient raised to a power, or negative 3 squared over b squared, so that exponent gets applied to each part of the quotient. Negative 3 times negative 3 is positive 9. I can't do b squared, so I'm just going to leave that as 9 over b squared. For example C, I'm going to apply this to the numerator and the denominator, so I get 4 to the negative 3 over 3y to the negative 3. Here I see that I'm not quite done simplifying. So the 4 to the negative 3 will stay there for now. This becomes 3 to the negative 3 times y to the negative 3. And now I have a couple of things that I need to deal with. First of all, 4 to the negative 3rd power is going to be 1 over 4 to the 3rd power, which means this is going to end up in the denominator. This 3 to the negative 3 then is going to end up in the numerator. So these two are going to switch spots. And then I also have a negative 3 on my y, so my y is going to be moved up into the into the numerator. So because of these negative exponents, my fraction is going to flip itself over. So I'll end up with 3 cubed in the numerator. That will make it a positive 3 exponent. A y cubed in the numerator. And my 4 cubed in the denominator. So I took care of the negative exponents, and now I can actually multiply these out as well. 3 cubed is 27. That's just 9 times 3. The y cubed I can't do anything about. And 4 times 4 is 16, times 4 is 64. So this one had a few more steps, but I really just have to do it step by step, just follow the rules, apply what I know, and it's pretty easy to get through.